Let's say from the bottom to the top is the perceived lightness scale. So black would be at the bottom and white would be at the top. As we go this direction, we're going through the hue circuit. We'll start with blue-violet. How bright do we perceive fully saturated blue-violet to be? Pretty low on the lightness scale. And cyan we usually think of as being a pretty bright color, but not the brightest. Green at its fullest saturation we probably think of as a little darker than cyan. Yellow is the closest to white, right? It's a very bright color at its fullest saturation. Red is maybe something like this. Magenta is probably going to be around the middle. All these different intermediary hues are going to have different values of lightness, different approaches to white or black based on which cone cells are involved in perceiving them. So here's a really nice one I made on the computer. Where this whole thing really hits home is if you wrap the ends together. So this cylinder kind of represents the space that would contain all colors, right? All grayed out colors, low saturation colors would be inside here. Colors approaching white would be at the top, colors approaching black would be at the bottom. But full saturation hues around our hue circuit are not just going to go around the equator like you see in a lot of diagrams, but are actually going to go up and down on this roller coaster path.